internal variability, according to Desser and Kai et al. 2015, it is refers to as the natural variability of the climate system that occurs in the absence of evolving external forcing and includes processes intrinsic to the atmosphere, ocean, land, cryosphere, and their interactions. It is at force and does not cause long-term temperature trends and a variations over time in one or more measures of climate resulting from natural causes. These changes are instead caused by interactions within the climate system itself, often involving positive feedbacks. Positive feedbacks describes any processes that intensifies an initial effect, generally a push that eventually increases the magnitude of initial disturbance. This causes some initial change to grow larger and moves the system out of its original equilibrium state. One example of internal variability is El Niño and the La Niña cycle, but let me discuss their definition first. El Niño, the warm phase, means little boy or Christ child in Spanish. During El Niño, trade winds weaken, warm water is pushed back east toward the west coast of the America. El Niño can affect our weather significantly. As shown in the picture, El Niño causes the Pacific jet stream to move south and spread further east. During winter, this leads to wetter conditions than usual in southern U.S. and warmer and drier conditions in the north. On the other hand, La Niña means little girl in Spanish. It is also sometimes called El Viejo, anti-El Niño, or simply a cold event that has opposite effect of El Niño. During this event, trade winds are even stronger than usual, pushing more warm water toward Asia. When upwelling increases, it brings cold, nutrient-rich water to the surface. This can also lead to a more severe hurricane season. As shown in the picture, during La Niña winters, the south sees warmer and drier conditions than usual. The north and Canada tend to be wetter and colder. El Niño and La Niña affect atmospheric circulation pattern and influence global climate. Warmer and colder than average ocean temperature in one part of the world can influence weather around the globe. Both phenomena are two opposing climate patterns that break these normal conditions. Scientists call these phenomena the El Niño Southern Oscillation or the ENSO cycle. The said event can both have global impacts on weather, wildfires, ecosystems, and economies. Episodes of these phenomena typically repeats itself on a timescale of about 5 years, but these changes are short-term, only lasting a few years, but they don't occur on a regular schedule. Generally, El Niño occurs more frequently than La Niña. While El Niño increases global temperature, La Niña decreases it. Another example of internal variability is Arctic Oscillation, or the AO. It is one of the main modes of variability of the Northern Hemisphere winter, also referred as Northern Annular Mode, or the NAM, which associated with changing circulation pattern of air pressure in the Northern Hemisphere. Thus, AO can have a strong influence on weather and climate in major population centers in North America, Europe, and Asia, especially during winter. It is a back-and-forth shifting of atmospheric pressure between the Arctic and the mid-latitude of the North Pacific and the North Atlantic. This AO favors a cooler Arctic than usual and warm conditions across North America and Europe. And the other phase brings opposite weathers. It makes warmer than usual Arctic and colder weather in the subpolar regions. Nevertheless, because of this seesaw effect, the AO has little effect on global temperatures, but can significantly influence local and regional weather.